Good afternoon, friends. I'm Abhishek. Singapore is known for city in a garden, and based on a study in 2017 by MIT, we are the #1 green city in the world. So this means it cements our position that we are the most green city. And to maintain this greenery, there are various stakeholders works in the back end. All the trees which are next to the roads, highways such as ECP, PIE, major roads and minor roads are being managed by National Parks Board. However, the trees which are within the housing estate are owned by Housing Development Board and managed by Town Council. This is about the trees which are being managed by SDB, owned by SDB and managed by Town Council. So within this project, we have developed one technical tree registry system for Town Council, and the scope also covers commissioning one-time tree survey for all the trees within the housing estates, which means the people who are aware of the survey means the officer has to go onto the ground, open a mobile app, plot an asset, and then update the attributes about the parameters, about that asset. In this project, we are not doing the same thing. What we are doing is we are using Pointcloud technology. I'll show you how we are using the latest technology to reduce the time for tree survey. This project also covers training for town councils. So Singapore has 16 town council. We have divided 16 town council into 4 zones, and we have started survey for each town council from each zone. So this is our tree survey form. In a gist, we are collecting in the survey what is the location of the tree, what is the height of the tree, what is the girth of the tree. We are also collecting species and vigor. Vigor means whether it is a good tree, poor tree, excellent looking trees. And next to it, you can see there's a very dense 2-page form. This is used for tree inspection. So once officers goes onto the ground, they have to inspect the tree and they check a lot about trees. You can see the form is really big, and we have converted this paper form into a digital form. I told about LiDAR Pointcloud, and this is actually a picture of Singapore Botanic Garden bandstand. And Pointcloud means it is an X, Y, and Z, each and every point in the 3D dimension. This picture consists of 46 million points. And 46 million is not a crazy number when we deal with Pointcloud. Imagine the number of points or the data we have collected when we have done the survey for all the housing estates within Singapore. Something wrong with the, okay. If one picture has 46 million, imagine the millions and billions of points we have handled. So Pointcloud data has been collected in various ways. This is an airplane. Airplane has a LiDAR sensor attached. It emits a beam to the ground, and when beam returns, it actually returns with a lot of data. It returns with the intensity, whether it hit on the table or it hit on the wood or it hit on a car. So when it returns with the intensity. It's something like we are hitting here, it is returning us. We actually did a classification for this data. And what you are seeing here is airborne data obtained from SLA for hot park. On the next, it is mobile LiDAR. On this car, there are 2 mobile LiDAR scanners attached. Actually, it throws 100,000 to 1 billion beams per second. When it hits, it returns with again a lot of data. And on top of it, there is a 360-degree image, panoramic image camera attached. This is mobile LiDAR data which we have obtained from Singapore Land Authority, and this is our town council areas which is being managed. You can see that going in, there's a lot of trees here. So this is the data what we have collected in this project. Moving on to the next. There are some areas where car cannot go in. So we are using terrestrial LiDAR scanner. This has been used very limited. This is for Bidadari area, what you are seeing onto the screen. So airborne LiDAR cannot penetrate to some of the location where the canopy is very dense. That's where we are using terrestrial LiDAR data to collect. This has been used very limited in our system, however is still used. And this is another one we have used extensively on the ground. There are areas within the town council where people has to walk. Actually, you can see this man is holding a 360-degree panoramic image camera as well as a LiDAR camera attached to it. And these are the handheld LiDAR which people are carrying. So actually it is collecting the same data, what you have seen, and we are actually processing this data. On to the next. Here you can see the data which we have collected is actually loaded into a platform and published as a map service. On the left you are seeing an ArcPro, on the right you are seeing Orbit platform. And once the measurement has been taken, the point has been automatically plotted onto the map. So how this thing change? People doesn't need to go to the ground to do this. And it is well integrated with ESRI. The same way girth of the tree can be extracted. Onto the next screen you will see, I was actually checking the data and I realized there is one road, there is no tree near Muscat Street. And I was thinking, how is it possible that some road in the Singapore where are no trees? So actually I opened a 360-degree image. Yeah, there are places where there are no trees. But actually what it shows evidence-based processing. We have the images, we have the point cloud data available in the system anytime. And we can always open and check. I'm just telling you that when a surveyor going onto the ground, these are not normal surveyors. For tree survey, it's something like doctors going onto the ground. These are tree doctors. Those are known as arborists. They goes onto the ground and their time is very precious. We don't want them to do the job of a nurse. We can get a people of few dollars per hour to collect the data and sitting into the office to extract all these basic parameters like location of the tree, height of the tree, girth of the tree are automatically extracted. And when they go onto the ground, they only update the species of the tree, which is like a doctor's job, or vigor of the tree, see how good the tree is. So we have actually offloaded a lot of work of the arborists going onto the ground. So this is the benefit we are bringing using this technology. Next, I'll show you that how officers are actually doing the inspection onto the ground. So here we have used ESRI mobile apps such as Tree Survey. We have used for Collector. We have used for Tree Inspection Workforce. We have used ESRI Dashboard. The solution is fully integrated with ESRI suite of product. This is the Collector and Workforce in iOS and Android platform. This is to show that the application is available. On the left, you are seeing iOS, Android for Collector, Workforce, iOS and Android version. So on the next, I'll show you that how we are doing the tree survey onto the ground. So this is an iPad version, and you can see that the trees are already plotted. And for species, we mentioned to be verified. All these are species shown. arborist just went onto the ground and he found that the girth is already pre-populated, the height is also pre-populated, and they are just selecting the species. We have loaded all our species name already into the system. They can quickly find it and update it. And the same way they are doing for vigor. This is interesting, QR code. Like you have just scanned the QR code to ask the question. We are actually putting QR code on some of the trees. And this is where we are assigning a code, or means assigning a primary key in the technical terms, or a name to the tree. And if you see closely, it is www.trees.sg with a query string, which is a tree ID. So our arborists are actually having a pre-populated tree QR codes, and they will just place onto the few trees which are significant, or in the park where it is difficult to find the orientation for the trees. And the same app is available on the iPhone. I'll show you how it is going to use in the next slide. This is how a single QR code is being used in multiple levels. As a member of public, if you go scan the QR code, something looking like this, you will be redirected on trees.sg, where you can see the basic parameters which is linked to it. You can drop an email to the tree and all. However, if the same QR code is being scanned by our applications, it behaves differently. It behaves how to access the data. On the next screen, I'll show you how we are using it for the inspection. So if an officer goes onto the ground doing the inspection, so here you can relate it like a child has been born, a name has been given to the child. Now it's the usual checkup going on every 1 year, 2 years. So this is an iPad again. The search is based on the QR code. We are not on the where search by address or name. We are just scanning the QR code, and actually it is searching the tree in the back end, and see it is highlighted that this is the tree. And once we click on this tree, it is actually highlighted onto the map. And that's where you can do the inspection of the tree on the ground. So the same details are what has been filled earlier are there. Start tree inspection with the general details like how much is the lean there, arborist can update. It is the inspection which is being used. Moving forward, the tree inspection works. What my arborist friend told me is it starts from the crown. First check how is the crown, then goes on to the branches, then goes on to the trunks, then goes on to the roots. Okay, still not end. Then look for the nearby condition, that whether is there any site conditions, whether it's obstruction somewhere. So you can see how many things people have to fill in. Last but not the least, follow-up action. GP cannot handle it, send to specialist. So the same way we have the follow-up means next level of tree inspection, second level of inspection has to be done, which can be flagged into the system. The same app you are seeing is also available on the iPhone. So this is whole of tree inspection we are taking care for HDB owned trees where town councils are gonna use. Next, like we are going for usual checkups, next thing, sometimes all of a sudden we fall down, problem happens, go to the doctor again. So we have next level, tree incident. So if an incident happens, we just look onto the same tree and we can highlight that what are the incident happened, means if there is a trunk failure happened or branch failure happened, and we'll update at what girth it has been failed and what day it has been failed. Do we need to remove the tree, or we just one branch fall, we can keep the tree. So eventually the record of the inspection is actually tagged with the tree. So there is one tree, it has a survey, it has inspection, if it has an incident, it has further inspection. Actually it is storing whole of the medical history of the tree in the database, and all the changes in the back end are being tracked. So again, the same thing is available on the mobile app, as well as tablet. And it works on iOS and Android both. On the next, I was talking about incident happening, inspection happening and all. But how it works is we do inspection of the trees on a regular interval, 1 year, 2 years. Some trees we have to inspect 1.5 years, some trees 6 months. So this is a workforce application where a task has been assigned. We don't assign tasks on a daily basis. We assign on a monthly. It's rain, shine thing. People has to go onto the ground. So workforce has been used. Okay, so the video started. So that's where it is assigning a task into a particular place, just assigning an incident to myself. One of the thing here you can see, it shows assign, and it shows the green mark, means I am working. So means on the app, it shows that I am available. So I start inspection from the app, and then it opens data collector to do all the inspection thing. We have collected a lot of data. Now how the data is being used? We have published a dashboard for the office for NParks, and it has many widgets. We have got the various base maps, legend, search, normal old search is there. And here we are showing that how we can see data of a town council, 40,000 trees here. You can see that immediately all the height girth updated. We can expand a specific widget, and by just moving onto the mouse, it is telling me that how many trees of a particular height available. We have done the same thing for the girth of the tree. You can see that for a particular girth, how many trees are available. We can, for easy viewing, we can do some of the scrolling, and eventually the same thing can be done for species. Users can actually go and drill down from an MP ward to a smaller managed area, means the smaller managed area to then place. See, here you are seeing the girth. And as we are collecting data for the species, vigor, and level, because in the HTB, some trees are planted on a level 4, level 5, level 6. All this data is available. So now I'm searching how many Samanania saman trees are there in EngMoQ. I know there are 682 trees available. And I can go further details that what is the height of the tree of 682. I know for 20 meter height, I have 14 trees available. And what is their girth? So all this data can be quickly churned out by just few clicks. The same dashboard has been given to town councils, but they cannot see other town council data. So access matrix has been taken care. Here you are seeing that within an MP ward, EngMoQ Hogang Town Council has been looked out. We can see the tree species for each tree, how many species are there, the vigor level, and further details. From this screen, actually, you can drill down to a single tree. You can actually see the image of each and every tree onto the ground. See, I'm seeing just finding out 564 of a particular height. And by just click onto the map, I can see the picture of the tree also, which has been collected. So all the way from a city level to a tree level, all this thing available in one single dashboard. We have open APIs also, actually. We are not saying that only ArcPro can be used. We are using here Orbit platform, where the tree height has been captured through a separate platform, and the dots is manually created. On the next screen, you can see that we are using APIs. So once the data has been extracted manually, it is just stored in a shapefile or JSON. And once this JSON, we can load into the tree registry system using ESRI APIs. So what we are doing is we are just taking the data, and here you can see we are using QGIS. So we are open for many, many platforms. And we are loading approx 155 features into the database. So it takes few seconds to load, and rudimentary way of checking how many true are there, 155. And now on the QGIS screen, you will see that we have 155 trees available. So the APIs allows to load. So we have faced some of the challenges. We have faced data preparation challenges. We have faced scalable architecture. So data preparation is like, if we just go vendor to do the tree survey, where to start? So we have to give them manageable work units. So we have taken each and every town councils. We have wrote some geoprocessing models, some more geoprocessing models. Scary ones are on my server. These are the beautiful ones here. And then we have come up with the work unit. So these, all the blue areas which you are seeing here, are the work units which are being used by the town councils for the tree survey. So this is all the area which is being managed by town council for their work unit area. Scalable architecture is one of the issue, and we sorted out. We have to make sure that workers are going to use, so it has to be available for iOS and Android. It allows offline editing of the map. It allows connectivity to external GPS like Trimble, R1, R2, EOS, Aero. It is like traditional old school way of surveying. We have APIs, we have complex access rights also. We have NParks, we have HDB, we have town councils, multiple town councils, we have town council workers also. So all these things are being controlled through complex access matrix, and you have seen an example of the drill down reports already. Last but not the least, we did a lot of training to town council with the help of our colleagues in Streetscape and Parks. Thank you. Hope you have liked the present.
Thank you, Abhishek. So we have a couple of questions that have come in. The first question is, how long did it take to implement the system, and what were the challenges faced? Abhishek, would you like to answer that?
Okay, that's a very, very interesting question actually. So, I know some of my developer friends also asked this question to me. Technically, the technical part took approx 3 months, a little over than 3 months. However, working with the town councils for the managed area to come up with all the collaboration with Singapore Land Authority for LiDAR data, to work with GPS Lands, who is a subcontractor for Pointcloud data collection, the whole process and the collaboration took a little longer than that, but it's less than a year. So it's not that it has taken a lot of time. And at the same time, we worked with officers onto the ground to know their challenges. And we also worked with the external contractors and surveyors on how they work onto the ground. And then we have taken the feedback and implemented it into this, like QR code. They told us that going onto the ground, finding a tree for the tree inspection is difficult. So we thought on a solution, and then we realized it can be solved through a QR code. So this is a journey which we have gone through with various stakeholders.
I hope that answered your question. There's another question that is here. What are some of the feedback from town councils regarding this system?
Okay, so as part of change management, when we were giving the training, actually when we started this, we never thought that we need an API to be exposed. But there are few town councils who are very advanced. They say, can you expose API and we can integrate into our system and we can enhance our app, because they have an app for inspection, but it has no map. But it is linked with their finance system. It is linked with their work order system. So we are exposing APIs for them. And that's where we thought that APIs are helpful. Actually, the whole system has APIs and microservices. All the way from login to tree inspection, work assignment, tree incident, tree all the tree related tasks, for example, tree inspection, is all exposed via API. And once the API is exposed, means they know the whole details, what they are doing, and they can build their own app. Obviously, they need still a login from us, so only authenticated user can make changes. So this was some of the very forthcoming town council come up and ask this thing, and we work with them.